General seekers of truth. In this video, we will look at graphs of exponential functions and logarithmic functions. Now, in some of our other work, we've solved equations, and now we want to look at these as a graphical approach. So let's start with a simple equation, a function, f of x is equal to 2 to the x. So this is clearly an exponential function. It meets our description, our criteria. And many times students say, well, I don't know how to get started. Well, if we don't know how to deal with a function, maybe we should the easiest thing to get started with is just making a table of values. Okay, so tables of values are excellent for this sort of thing because they help us to visualize these particular types of graphs. So let's say I have some values here, x and then f of x. Okay? And we should always start out with, some of the easier, or quote-unquote, simpler numbers to work with. So let's say x is 1, x is 2, x is 3, and of course, let's not forget 0. So when x is equal to 1, f of x is 2 to the first, so that's just 2. When x is equal to 2, you have 2 squared, so that's 4. For x equals 3, 2 to the third is 8. When x is equal to 0, 2 to the 0th is 1. And we should also try some nice negative numbers. So negative 1, negative 2, negative 3. Okay. So 2 to the negative first is just 2 to the first and the reciprocal of that. So that's going to give us 1/2. Okay. 2 to the negative second is the reciprocal of 2 to the second, so that's going to give us 1 over 2 squared, or 1/4, and then finally 1 over 8, 1/8. So now if we put this onto a graph, all right, so if I have this graph here, and I graph this function with just these points that we had earlier. So when x is 0, y is 1, and that's this point here. At 1 you have 2, at 2 you have 4. It's right about here. And then at 3 we have 8. At negative 1 we have 1/2, so this looks pretty small here. At negative 2 we have 1/4, and this is getting very, very close to the y-axis. So putting all this together, I think we can extrapolate these points a little bit, and we can see that they will follow this pattern here. Something like that. And when we think about this, some nifty and important features of this graph. First is that it grows at a very, very fast rate. We say that it grows at an exponential rate. And if you notice something here, that on the left side of this graph, even when you put in big negative numbers, you never get down to 0. You never actually touch 0, because a positive base 2 to any power will be a positive number, even if that number is very close to 0. So we can say a few things, that the domain of this function, the domain of f of x, right, the domain of f of x is all real numbers. You can put anything in that you want for x, so negative infinity to positive infinity. Excuse me, I don't know what's going on there with my drawing. And the range of f of x is all the positive numbers, all the numbers from 0 to positive infinity. We can also discuss maybe some of the end behaviors. So the limit here as x approaches infinity of f of x, so in other words, as x gets very, very large, you can see that f of x will approach positive infinity. And going in the other extreme, if we were to look for the limit as x approaches negative infinity, in other words, we put in very, very large negative numbers, then you would get a number that is very, very close to 0. In other words, you have a horizontal asymptote here at y equals 0. So this is a nice start for us to discuss and talk about graphs of exponential functions. In the next video, we'll talk about some transformations on this graph and see where that leads us. Thank you for watching and have a wonderful